Hey everyone! Today we are going to learn about Guass Jordan, but I first want to do a review of Kramer's rule from last class. I know this one says by hand and this one says with a calculator. If you have time, I would highly recommend trying this one by hand because I just looked at your quiz and there will definitely be one on the quiz that looks like this that you do by hand. There will also be one that you can do with a calculator on the quiz, so keep that in mind because there will be a non-calculator and a calculator part of the quiz. So I would pause the video now and try the warm-up. And then when you come back, I will show the answers. Alright, now that you've tried the warm-up, here's what it looks like. So just a reminder, Kramer's rule. You first find the determinant of just the left side of the equation. That's d. We got 5. Dx is you replace the x column. Dy is you're replacing the y column. Find the determinant again, multiply diagonals and subtract. You should get 25. Same with y, you should replace the y column with your answer column. Get 75. And to find x, you do dx over d, divide, and then y is dy over d, get 15. I didn't show all the work for if you had done this one by hand, but hopefully here are the answers that you got. And then when you divided, you got the -2, 4, and 5. Refresher on elimination because it comes in helpful today. Remember with elimination, you can multiply an equation by a number and then add them together, and then that will eliminate. Here we eliminated like the x's. So that's how we do elimination. This one looks like they subtracted instead of added. I usually do adding for my elimination, but subtracting is also good. So what that leads us to is solving system of equations by the Guass Jordan elimination method. So this is the third way to solve systems of equations. So one more way. So what it looks like, we are going to write a system of equations as a single augmented matrix. So what that means is you're going to take your system of equations, the coefficients from the variables all go on the left side, and then your answer column goes on the right side of this bar. So when we manipulate this matrix, your answers are going to end up being in this answer column, which we'll see on the next slide. So what our goal is we are going to manipulate this matrix until we have the identity on the left side, and then everything over here are your answers. So like the top one is x, next one's y, this one's z. So this is another way to solve for x, y, and z, but by manipulating using Guass Jordan. This is also called reduced row echelon form. So reduced, it looks like a B, let's try again, row echelon form. In your calculator, it's going to look like the RREF. So that stands for reduced row echelon form. So a lot of times I just talk about like, you want to RREF that, but really what you're doing is Guass Jordan and you're getting that reduced row echelon form. So different rules to get your augmented matrix to look like the reduced row echelon form. The first thing we could do is we could switch 2 rows. So say, like you could notice in our goal, we want a 1 in the upper left-hand corner. So we want 1s in the diagonals and 0s everywhere else. So one way to meet that goal is in this matrix, I could switch row 1 and row 2 to get that 1 up into the first spot. So the way I could write this is I could just write switch, I can't spell, switch, row 1 and row 2. So whichever one I want the final product, I guess switching doesn't matter, so never mind, we'll come back to that. So all I've done when I switch row 1 and row 2 is they totally switch. So 1, -2, 2, 0 is now at the top, 5, 2, -1, -7 is next, and the third row didn't move at all, so it stays the same. The next option we could do to try to get that goal of the identity matrix on the left is we could multiply a row by a non-zero scalar. So if I had wanted to try a different method to get a 1 in the upper left-hand corner, I could multiply this whole row by 1/5. Maybe not the best idea because we've got like 2, -1, -7, but it is an option. Sometimes it works out really well. So I'm going to do 1/5 multiplied by row 1. And that means I'm just going to multiply row 1 by that 1/5, and everything else stays the same. So it turns into 1, 2/5, negative 1/5, and negative 7/5. And everything else stays the same. The third manipulation we can do is we can add a multiple of one row to any other row. So you could either just like add two rows together or subtract two rows, or you could multiply a row by something first and then like add or subtract it with another row. So for example, say I wanted to, let's see, we could do row 1 minus 4 times row 2. So if we do that, if we do row 1 minus 4 times row 2, when I do 4 times row 2, I get a 4 here, and 5 minus 4 gives me that 1 in this spot, which is a goal. So row 1 minus 4 times row 2. So we've got 4 times this is 4, so when we subtract we get a 1. 4 times 2 is 8, or negative 8, so 2 minus negative 8 is going to be 10. If we multiply by 4 here, we get 8, so negative 1 minus 8 is negative 9. And row 1 minus 4 times 0 is 0, so we're just left with negative 7 still. And then we've only manipulated, notice I started with row 1. So because I wrote row 1 first, that's the row that I'm replacing. So whatever I write first, that's the thing that I'm going to replace. And everything else is going to stay the same. Just another quick example of that. Instead of doing a multiple, you could also just do row 2 minus row 1. So if I did row 2 minus row 1, that's going to do 1 minus 1, which will give me that 0 in this position, which is a goal. So I'm running out of room a little bit, so I'm going to write it down here. So row 1 stays the same. Only row 2 is changing because row 2 is what I wrote first, so row 1's the same. Then if I do row 2 minus row 1, so 1 minus 1 is 0. Negative 2 minus 10 is negative 12. 2 minus negative 9 is 11. 11. And 0 minus negative 7 is 7. And then third row did not change at all. So we have now reached one of our goals, which is to get 1, 0, 0 here. And then from there you would move on to continue trying to get the 0, 1, 0, 0, 0, 1. So this is the different options for manipulations that you can do to try to get to that reduced row echelon form. So let's put this into action with this smaller matrix. So if we want to solve this system by Guass Jordan, the first step is putting it in an augmented matrix. So you're going to start with writing negative 2, negative 6, 3, 6. You draw your bar and then write your answers. Personally, I always try to get a 1 in this position first if it works out well. To do that, we've got a few different options. I could multiply the top row by negative 1/2, but that's going to give me some gross fractions. So another thought, I do like doing that first. Personally, I think in order to avoid the fractions, I'm going to aim for a 0 in this spot first. So if I multiply row 1 by a negative 3 and then add it, that's going to give me a 0 in the spot. So the step I'm going to do is row 2 plus negative 3 times row 1. And when I do that, row 1 stays the same. And now I'm doing row 2 plus negative 3 times row 1. So this turns into a 0. Negative 9 plus 6 is negative 3. And negative 45 plus 18 is going to give me negative 27. At this point, looking for what might be easiest, I noticed that this -3 and 3 match. So I could use those to get me another 0. Because if I add 0 and -2, that won't change anything. But if I add these, it's going to turn into 0. So my goal is to get a 0 here. So I'm going to do row 1, because that's what I want to replace, plus just row 2. So when I add those together, I'm going to get, we've got row 1, so -2 plus 0 is just -2. 3 plus -3 is 0. And 15 plus -27 is 6. Oh, wait, no, it's not. It's -12. Then the bottom row does not change. So we're going to get -0, -3, -27. So we're getting closer. So far, we have our zeros. Now's a step that I like the best. Getting my ones, I always just multiply by their inverses. So, or their opposite reciprocals, really. So the first row, if I want to turn this into a 1, I can multiply by -1/2. So -1/2 times row 1. Sometimes you can combine steps together. So I also could do a step with row 2. And if I want to turn that -3 into a 1, I could multiply by -1/3 times row 2. And that'll turn this into a 1 as well. So what our new matrix will look like, -1/2 times row 1 will give me a 1, 0, and a 6. And -1/3 times the bottom row will be 0, 1, and 9. Ta-da! So what we've got here is our top answer is our x, our bottom is our y, so x equals 6, and y equals 9. All right, next example. You could try it on your own first if you want, or you can just follow along, your choice. First, going to set up that augmented matrix. So 1, 1, 6, 3, -5, -6. Nice, we already have a 1 in the upper left-hand corner, so don't have to mess with that at all. So I want to turn the bottom one into a 0. We could multiply row 1 by -3 and then add these together. So we're going to do row 2 plus -3 times row 1. You'll notice I a lot of times will use just like adding negatives rather than subtracting. For some reason I just don't like subtracting very much. So when we add those together, we get 0. -3 plus -5 is -8. And -18 plus -6 is -24. Next, we could multiply, to get to that 1 in this spot, we could multiply by -1/8. So if I do -1/8 row 2, that'll give me my nice 1s. So I've got 1, 1, 6, 0, 1, 3. And then our final step is just getting that 0 in the upper right-hand corner. And we could do row 1 minus row 2. So we've got 1, 0, 3, 0, 1, 3. So finished it, x equals 3, y equals 3. So as you go, it should get a little bit quicker. You're just looking for any manipulations to turn these 1s and 0, like the numbers into 1s and 0s. All right, I'm going to stop this video now, and then I'm going to do the next 2 examples or 3 examples on the next video. So please move on to the next video to get the rest of the lesson.